Alright, so this is part 2 of the video where we are finishing the Ferris wheel question. So we are on H and G. Sorry, H and I. In G, all we had to do was plug in 6 for the time, and it came out to where we could actually use our unit circle knowledge to get the exact answer. Let's write that this is, in fact, the exact. And then we could also, once we plug it into our calculator and we cut off those decimals, we get the approximate answer. Alright, so find the exact time that the rider's position is 43 feet above the ground. So the exact time. So what we're going to do, we're going to take this height and set the whole equation, the height equation, equal to 43. So 43 is the height. We can set it equal to 26 sine of 2 pi over 48 times time plus 30, because that is 43 is the height. So we're just going to now find the only missing variable, t. So we are going to subtract 30 from both sides. That cancels out. We're left with 13 equals 26 sine 2 pi over 48 times t. We're going to divide both sides by 26, and we get 1/2 is equal to, that cancels out to 1, sine of 2 pi over 48 times t. We're then going to take the inverse sine of both sides. So inverse sine of 1/2, and that is going to be equal to, when we take the inverse sine to the right, we're left with just the input. That gets rid of this sign, 2 pi over 48 t. Now, since we did the act of doing the inverse sine, we actually get two answers. Inverse sine of 1/2 gets us two answers. It gets us pi over 6. So pi over 6 is equal to 2 pi over 48 t. And then 5 pi over 6, where sine is also positive 1/2, is equal to 2 pi over 48 t. Because let's think about this 43 feet above the ground, looking at our map. So 43 feet above the ground is going to happen there. If we're at 30 feet at the center, we start at 30 feet, time will pass and we'll get up to 43 feet, but it's going to happen twice. We're going to go 43 feet, then we're going to go up to where it peaks, and then we're going to go back down through 43 feet as we come down to 30, then 4, and then all the way back around. So this 43 feet happens multiple times within that first rotation. So we can go ahead and get these two answers, pi over 6 and 5 pi over 6. Now we just need to solve for t. We need to divide both sides by 2 pi over 48. So t is going to equal, when we divide fractions, we keep the top, change that big divide to multiply, and we flip this, 48 over 2 pi. The pi's will cancel out. We'll get 48 over 12, which is 4. So time is equal to 4 seconds. That's when it's first going to hit 43 feet above the ground. When you do the same thing here, 2 pi over 48, that cancels out, and we're left with time is equal to 5 pi over 6 times 48 over 2 pi. That's going to end up being 20 seconds. So that is the second time that we'll get to 43 feet within that first rotation. Letter I, find the approximate time. So we're not going to be able to use our unit circle knowledge for this. We're just going to have to type it into our calculator. Find the approximate time that the rider's position is 24 feet. So let's just look at the unit circle. And same thing, our center's at 30 feet. So we're going to be at 24 feet, somewhere in between 24 seconds and 36 seconds. And then we're going to see it again somewhere between 36 seconds and 48 seconds, because we'll get to 24 feet twice. So all we have to do is set the equation equal to 24, just like we did. So 24 equals, just so we can see, the equation is 26 sine 2 pi over 48 t plus 30. All right, subtract 30 from both sides. We get negative 6 equals 26 sine 2 pi over 48t. Divide by 26, we get negative 6 over 26 equals sine of 2 pi over 48t. We'll take the inverse sine of both sides. Negative 6 over 26 equals 2 pi over 48t. And then we'll divide both sides by 2 pi over 48. This is definitely not a unit circle value. So we're going to get t is equal to inverse sine of negative 6 over 26 all over 2 pi over 48. Now I'm just going to type this into my calculator, and I am going to be careful. I'm going to put parentheses around the entire top and around the entire denominator, and then we will get t as, let's type it in, inverse sine of negative 6 over 26 divided by parentheses 2 pi over 48, close the parentheses. We get negative 1.78 seconds. Negative. This doesn't make any sense. The negative is what's a little confusing. But let's look back at the graph to see what that actually means. So we know we're going to be down here. So instead of going positive seconds up and around, it just kind of gave us a shortcut. It's like, oh, if you just go negative 1 seconds back, you'll find out where you're at. So instead of it being negative 1.78 seconds, we could kind of just take that and go 48 minus that 1.78, and that'll give us a time of 46.22 seconds. That is in theory, the last time that it will get to 24 feet within that first rotation. But there is that second time, and you can see that it's going to happen after 24 seconds when we get to that 24 height off the ground. Because at 24 seconds we're at 30, we're going to keep, and then we'll be going down. So let's just take that 24 seconds and add 1.78, and we'll get 25.78 seconds as our other time that will be at that height. Great.